The section that we're going to be discussing today is Unit 1.2, Day 1, which is multiplying two binomials using what we call our FOIL method. When we look at first what we're trying to achieve, our objective for today is to basically just multiply two binomials using our FOIL method and learning what we call squaring a binomial. So we're going to look at two different things. So we're going to look at the FOIL method, and then we're going to look at squaring a binomial. So the first thing we're going to look at is just some vocab terms, and each one of these vocab terms kind of piles off on the other one. So the idea of what we're looking at here is just recognizing what these values are. So the first one is monomial, and we can kind of look at the roots of the word here to understand what it really means. And so the root of this word is mono, and so what this term means is that it's a one-term expression. So mono is one, and so this is a one-term expression. When we look at binomial, we can look at the root of the word bi, which would be two. So this is a two-term expression. And then as we look at the rest of these, trinomial, you can probably guess, this is three terms. And then the last one, poly, is basically just another word for multiples. And so this would be multiple terms. So once we get past three, we just usually call it a polynomial, meaning that there's multiple terms to it. And so there are some of the kind of basic vocab words there, and notice they're all kind of the same, that they're just going from 1, 2, 3, and then multiple terms for expressions. So first of all, as we kind of get into this lesson here, we want to go with some of the things that we know. And the first thing is the distributive property, and just kind of a basic example of how the distributive property works is we have some value out here that's multiplied in front of a set of parentheses, and we're trying to use our order of operations and try to simplify this, but with these parentheses it's not going to be simplified. So we're just going to take the value that's on the outside and we're going to distribute that to each one of the terms that are on the inside. So each one of those are terms. When we do this, we just multiply this. We're not combining them or anything like that, but we get a times b plus a times c. Now once we use the distributive property, we're kind of looking for like terms as well, but these are not identical to each other, so they're not like terms, and then that's simplified there. Now with the next one here, we kind of do the same thing, but the only difference is that this is more of a variable term rather than just a single number or a single variable, but we're still going to distribute the whole thing. So I'm going to multiply 2x by this and 2x by this term, and what I get from that is I would get 2x multiplied by 4x to the third, and then I would add this with 2x times x. Now with this, we just have to kind of understand how we multiply and combine values while we're multiplying them. So 2 times 4 would give us 8, and then x times x to the third is going to give us a final answer of x to the fourth. Notice that when I multiply those x's together, then it's going to give me a higher exponent. And then here, the same kind of thing is going to happen here. We have 2x times x, and that's going to give me 2x to the second power. And so that's just kind of the basic distributive property that we already know. Now we can take this one step further, and we're going to multiply what we call two binomials. Now remember, a binomial is a two-term expression, and so when we look at these, each one of these are binomials by themselves. So this one here is a binomial because it has two terms, and then this set of parentheses here is also a binomial because it also has two terms. And so in order for us to multiply these, what we're going to do is we're going to distribute the first term to the other binomial. So basically what that would mean is I would take this x, and the first step that I would have is to distribute this. And so I can distribute this x to both pieces, and so as a result from that I get x times 2x plus, because I'm going to use that same operation that's in between, x times 3y. And so that would be my first kind of distribution there. I can simplify that to give me 2x squared plus 3xy. Now with the second set, I still also need to distribute this one because this is still in front of that other parentheses. So I'm going to distribute that y to 2x and distribute the y to 3y. So when I do that one, I get y times 2x plus y times 3y. And when I do that, I'll get 2xy plus 3y to the second, because I have y times y. Now, at the very end, I'm going to combine my like terms. So basically, each one of these that I did, so this one here and this one here, these results here are going to combine together to give me one new expression. So I'm going to zoom out just a little bit so I have a little more space. But I'm going to basically put these together. So 2x squared plus 3xy plus 2xy plus 3y squared. And then I have two like terms right here in the middle. Both have the xy. And then what I can do with that is combine those, and I get 2x squared plus 5xy plus 3y squared. So the idea behind this one is I'm kind of, in a way, distributing twice. So if we see another binomial in front of another binomial, we're basically just going to use our distributive property twice. Now there is another way that we can do this, and it's what we call our FOIL method. Now the FOIL method isn't really any different than what I just showed you as far as multiplying two binomials, but it's a little bit easier way that we can organize our thoughts and kind of keep it a little bit more simple so that we're not going through and having a bunch of steps. Now the FOIL is just kind of an acronym, and the first letter of this acronym would be F, which stands for the first. What that really means is I'm looking at the first terms of these two binomials, and I'm going to multiply them together. So I'm going to take A and I'm going to take C and multiply them together. Those are my first terms in both of those binomials. So A times C. The next one, O, would be the outside terms. So I look at the two terms that are on the outside. So A and D. That's on the outside. It's kind of like the edges there, and we'll multiply those together as well and say plus A times D. Now the next one would be the inside terms. So I look at the two terms that are on the inside. So we have B and C right here. Add those to our expression. So BC. And then finally what we would have is we would have our last terms. So I look at the two last terms. So in this case B and D. Multiply those together and add those to our list, and we get B times D. So the idea of this whole FOIL method is just a little bit easier to kind of add those together and multiply them out. But if you really look at what is going on here, I took this A and distributed it to both parts. I took the B and distributed it to both terms in the other binomial. So it's really just the same thing of what we're doing, just an easier way to recognize it and kind of organize our work. And then we get our simplified answer right here. You know, if we had like terms, which we don't, this is AC, AD, BC, and BD, it wouldn't really make a difference. Now one thing that I want to give you as far as a special note, what we would want to always do is try to write your variables in alphabetical order. So when we look at a given term right here, I always wrote this AC, not necessarily the way that I multiplied it, but if I write these alphabetically, so AD, BC, and BD, what that allows me to do is helps me easily recognize like terms, because as long as they're all organized the same way, I can see if maybe something is a like term or not. So it doesn't necessarily have to mean the way that you multiply it, but it's usually helpful if you order these alphabetically. Okay, and so if we look at a couple examples, you know, I'm going to do the first one of double distributing, and then I'm going to do the FOIL method in order to do this kind of both ways. So the first one, I'm going to take my x and distribute it. So x times x is x squared. And then I'm going to take my other x, multiply it by this. Now notice what I'm going to do is I'm going to take this piece of it too. And so this is going to be minus 2x. Then I'm take my 1, distribute that, so plus 1x, and then distribute my 1 again, and I'm going to get minus 2. Now what I would do here is I look at these two things and I recognize that those are like terms, which I can combine those. And if you do this, you know, appropriately and everything is kind of ordered the right way, your combined terms or your like terms will always be in the middle. So I'll get x squared, negative 2 plus 1 is minus 1x, and minus 2, and there's my simplified answer. Now if I use the FOIL method, first, outside, inside, last, my first terms multiply together to give me 6x squared. My outside terms, so my 3x and my negative 1, would give me minus 3x. My inside terms, negative 2 times negative 2 times 2x, negative 4x. And then my last terms, negative 2 and negative 1, end up giving me a positive 2. And if you look at this, as I write them in this order, these two will combine. These are being added together. Remember I told you we're thinking of everything in terms of addition. These add together to give us negative 7x. So my final expression would be 6x squared minus 7x plus 2. And so that's using either the double distribution that I would call it or the FOIL method. Still kind of works out the same way. We still multiply every term with everything else and get our simplified answer. Now as we continue, we're going to look at multiplying binomials when it doesn't look like we're multiplying binomials. So if we're given a situation in which we have this particular expression, we have a plus b to the power of 2. That whole thing would be squared. Now one thing that we have to keep in mind is we're going to look at what this is and then what this isn't. Too often you see this mistake, and we want to make sure that we avoid this whenever possible. So let's first look at what this isn't. So if I take a plus b and I square it, this does not equal a squared plus b squared. The way that this works is that I'm telling you that I'm going to take the contents inside of this and multiply it by itself, whatever a plus b is. You know, and we can get into more examples when we do this in class, but I do not want you to make the mistake of just distributing the power of 2 to each one of those terms. What this actually is, so this would be all wrong, what this actually is, when I take a plus b squared, it's going to give me a different result. This is going to equal a plus b times another a plus b. So it's almost similar to saying x squared is equal to x times x. So if I take this and imagine that this is x, I'm basically multiplying it by itself. So whenever you see a plus b to the power of 2, it's a plus b times a plus b. So let's take a look at what that looks like. So we have an example of x plus 6 to the power of 2. First thing that we want to do whenever we have a problem like this, the easiest thing would be to rewrite this. So I would write this x plus 6 times x plus 6. And what that would allow me to do is that allows me to now use my FOIL method or my double distribution and kind of distribute these terms to each other. So I'll go ahead and draw my arrow. So x times x would give me x squared, x times 6, so that'd be plus 6x, 6 times x, another plus 6x, and then finally 6 times 6, which would give me plus 36. Now I can go on to simplifying this. So I have my two like terms here right in the middle, just like I told you. So x squared plus 12x plus 36 would be our final answer. And so there's our final simplified answer from x plus 6 squared. Now with the last one, it's a little trickier, but the process is still the same. So we have not just single variable or just a number. We have a coefficient with x, which shouldn't be a problem. So again, general rule of thumb, good idea to rewrite this. So 3x plus 2 squared is 3x plus 2 times 3x plus 2. And now I'm going to go through the same thing. This time I'll just use my FOIL method. So I'll write out my 4 letters here, and I'm just going to come up with the individual terms from doing that FOIL method. So the first terms would be these two. So 3x times 3x. Now that's a little tricky, but what we're basically going to do is we're going to multiply the numbers and then we're going to multiply the variables. So 3 times 3 is 9, and x times x would be x squared. So notice that we're not only just multiplying the numbers, but we're also multiplying the variables. So we get 9x squared. The outside terms would be 3x and 2. So 3 times 2 would give us 6, times x would give us 6x. The inside terms, 2 and 3x again, which we get 6x there. So 2 times 3 is 6 times the x. And then finally we get 2 times 2 on the last terms, which would give us not 6. I don't know why I wrote 6, but that is not 6. It would be 4. Now if I combine those all together, again, we notice that these are like terms. They would combine together to give us 12x. And so my final expression is 9x squared plus 12x plus 4. And so that's pretty much going to do it for our FOIL method and kind of multiplying binomials.